Hey, in this video we're going to do a couple of examples, one of them using the product rule and one of them using the quotient rule of differentiating functions. Okay, so for the product rule, we're going to use the function y of x equals cosine of x squared. Remember, that's cosine of x squared. I know it's written in a funny way. Cosine of x squared times x squared. Well, let's let cosine of x squared be our function f of x, and we'll let x squared be our function g of x. Now remember what the product rule said. The product rule said that y prime of x, in this case, is going to be equal to f prime of x times g of x plus f of x times g prime of x. Differentiate one, leave the other alone. Differentiate the other, leave the first one alone, and then add them together. So that's how to remember that. Well, let's differentiate g of x first because that's the easiest. So g prime of x is actually just equal to 2x. So we already know g prime of x, and we know g of x, and we know f of x. So the only thing left to find is actually f prime of x. So let's go ahead and do that. So, well, f of x is actually a composition of functions here. What that means is it's one function of another function. So we're going to need to use the chain rule to differentiate this thing. So f of x, let's write f of x is equal to u of v of x. And we're going to choose our u and v functions appropriately to make it easy to differentiate. Well, so u of v of x, what function shall we choose? Well, u of v, so the function u of v, well, we're squaring cosine of x. We're squaring cosine of x. So let's let u of v be v squared. And then that means that v of x must be cosine of x. And therefore, f of x, which is equal to cosine of x squared, is equal to u of v of x, because what u does to v is it squares it, and v itself is equal to cosine of x. So u of v of x is equal to cosine of x squared, because when you put cosine of x into the function u, it squares it. Alright, so the chain rule tells us that in this case, we actually have f prime of x must be equal to u prime of v of x times v prime of x. It must be u prime of v of x times v prime of x. Well, u prime of v, I'll write this over here, u prime of v is just equal to 2v. So that's nice and easy. So u prime of v of x is equal to 2 times cosine of x, because v of x is equal to cosine of x. So u prime of v of x is equal to 2 times cosine of x, and v prime of x is equal to negative sine of x, because that's what you get when you differentiate cosine of x with respect to x. If you don't know that, go check out the video about differentiating trigonometric functions, or go check out any textbook you like. There's a whole bunch of different reasons, a whole bunch of different explanations of why that's true. Okay, so v prime of x is equal to negative sine of x, and so now we know that f prime of x is equal to u prime of v of x, so that's equal to 2 times cosine of x, since u prime of v is equal to 2v, and now v prime of x is equal to negative sine of x. So f prime of x is therefore equal to negative 2 cosine of x sine of x. Okay, nearly done. And now we just need to put in everything, because we already have all the information we need. We've got f of x, we've got f prime of x, we've got g of x, and we've got g prime of x. So now we'll just use our nice little formula here. Okay, so therefore y prime of x is equal to f prime of x, which is equal to negative 2 cosine of x sine of x, oops, times g of x, which is equal to x squared, plus f of x, so cosine of x squared, times g prime of x, or g prime of x is just 2x. And we're pretty much done. Maybe we want to tidy it up a little bit by factorizing out the highest common factor. Let's go ahead and do that just for the sake of it. So what's the highest common factor in both of these? Well, we've got a 2 in both of them, we've got a cosine of x in both of them, and we got an x in both of them. So let's factor out 2 times cosine of x. So 2 times cosine of, why am I using blue still? 2 times cosine of x. Oh, we brought out an x as well. So actually 2x times cosine of x. And then we open our bracket, and what's left over? There's a negative here, so I'm actually going to write the negative part separately. I don't know why, it just looks neater that way. So let's write this part first. What's left over on this part? We've got just a 2. No, we just got a 1. No, we got a cosine of x. So cosine of x is left here. And then we're taking away whatever's left over here because we got that negative. So we're taking away whatever's left here. And the cosine of x has been removed. And one of these x's has been removed. So all that's left is just x times sine of x. And we're done. This is the final answer. That's what you would write on your exam paper. Okay, let's do one more example. This time we'll use the quotient rule. And I guess this is kind of interesting a little bit. So let's take the function y of x equals x to the power of m divided by x to the power of n, where m and n can be any numbers we like. Any numbers we like. Well, we know that this is equal to, from year 10 algebra or whatever, we know that this is equal to x to the power of m minus n. We know that this is equal to x to the power of m minus n. And therefore, by our regular power rule differentiation, we can easily see that y prime of x is equal to m minus n times x to the power of m minus n minus 1. Hopefully that fits in. Yeah, I think it just fits in. Okay, let me draw the 1 a bit better. Nope. There we go. Okay, so we know that that's true from the power rule. Let's go ahead and show that it's also true from the quotient rule, because we've also got a quotient of functions here. We've got one function divided by another function. So this is actually equal to f of x divided by g of x. And our quotient rule tells us that when we have this situation, as long as we know the derivative of f and g, we know that y prime of x is equal to f prime of x. So differentiate the top one, leave the bottom one alone. F prime of x times g of x minus, leave the top one alone, f of x, that's a horrible x, f of x, leave the top one alone, differentiate the bottom one, and then divided by the bottom one squared, divided by g of x squared. Okay, so now, well, we know that so f of x is equal to x to the m, so that tells us that f prime of x is equal to m times x to the n minus 1. And we also know, for similar reasons, g prime of x is equal to n times x to the n minus 1, because g of x is equal to x to the n. So now it's just simply a case of filling everything in and making sure it all works out. So y prime of x is equal to m times x to the n minus 1 times x to the n, that's f prime of x times g of x, minus f of x, which is x to the m, times g prime of x times nx to the n minus 1, and this is all divided by g of x squared. Well, g of x squared, that's x to the n squared we know that that's equal to x to the power of 2n. X to the power of 2n. We can simplify this a little bit just by splitting up this fraction. So we get, and also we can combine these two powers because they have the same base, and also this one and this one have the same base. We know that a to the power of b times a to the power of c is equal to a to the power of b plus c. Have a think about why that's true if you don't know. So what we get here is actually m times x to the power of, this is an m here. This is an m here. I made a mistake earlier. X to the power of m minus 1. So m times x to the power of m minus 1 plus n. That's combining these two right here. So m times x to the power of m minus 1 plus n. Divided by x to the power of 2n, and then we're subtracting x to the power of m times n times x to the power of n minus 1. Well, that can be combined as n times x to the power of m minus 1 plus n. And that is divided by x to the power of 2n as well. All right, let's go on to a new page because we've kind of run out of space here. So here's where we're at. We're at y prime of x equals, what was it again? I forgot. Y prime of x is equal to mx to the m plus n minus 1. Mx to the power of m, well, I'm going to write it as m minus 1 plus n. And that's all divided by x to the power of 2n minus n times x to the power of, again, m minus 1 plus n. And that's all divided by x to the power of 2n. Well, now we can go ahead and cancel out some powers because we know that a to the power of n divided by a to the power of m is actually a to the power of n minus m. So this 2n on the bottom, we can actually subtract that from this power because these have the same base. They both have a base of x. So what we're actually left with is m times x to the power of m minus 1 plus n minus 2n. Minus n times x to the power of m minus 1 plus n minus 2n. Is it starting to look familiar yet? It will be really soon. So this is equal to m times x to the power of m minus 1 plus n minus 2n. Well, what's n minus 2n? That's just negative n. So m times x to the power of m minus 1 minus n, or m minus n minus 1, minus n times x to the power of, again, m minus n minus 1. And finally, let's factor out x to the power of m minus n minus 1. Factoring that out, we get m minus n times x to the power of m minus n minus 1. So this is exactly what we thought it would equal. Oops. This is exactly what we thought it would equal given the product rule. Given the quotient rule, given the power rule, rather. We knew that because we can already simplify this as x to the power of n minus n, we knew that that when we differentiated it was going to be m minus n times x to the power of m minus n minus 1. So what was the point of all that? Just for fun. No, just to get you used to the product rule and to show you that actually, it still works in this case as well. Okay, hope that was useful. Thank you very much for watching. See you guys in the next video or the next time. Take care. Bye.